March 11th, 2011, a 9.0 magnitude earthquake.
In Sendai City, a tsunami reached as far as 10 kilometers inland.
20,000 people dead. 120,000 homes gone. Just gone. And Japan had a choice to make. They could accept that the ocean owns the coast, that tsunamis are a fact of life, that some disasters simply cannot be stopped. Or they could build a wall so massive, so expensive, so controversial, that it would reshape 400 kilometers of coastline and cost more than the GDP of Portugal. They chose the wall. And what happened next is one of the most ambitious and divisive engineering projects in human history. The scale of catastrophe. Let me paint you a picture of what actually happened that day. The earthquake wasn't the killer. Earthquakes, Japan can handle. They've been building earthquake-proof structures since the 1920s. No, the real destroyer was what came 14 minutes later. A tsunami, 50 feet high, moving at 500 miles per hour across the Pacific. And when it hit the northeastern coast, the Tohoku region, it didn't just flood towns, it erased them. The old seawalls, the ones designed for 26-foot waves, obliterated. The town of Taro had what they called the Great Wall, a 10-meter concrete barrier they were proud of. The tsunami hit it at 12 to 15 meters, scouring out the foundations, toppling the concrete, and killing hundreds. In Kamaishi, they had built the world's deepest breakwater, 63 meters down into the ocean floor. Cost $1.6 billion. The tsunami snapped it like a breadstick. And here's the truly horrifying part. Japan thought they were prepared. They had walls, they had warning systems, they had evacuation plans, and still 20,000 dead. So the Japanese government looked at the rubble and made a decision that would define the next decade. Never again. The two-level philosophy. But here's where it gets interesting, because Japan didn't just decide to build bigger walls. They completely rewrote their entire disaster philosophy. After 2011, engineers sat down and admitted something uncomfortable. You cannot build a wall tall enough to stop every tsunami. A 1,000-year event like the one that just happened would require walls so high they'd block out the sun. So they created something called the two-level system. Level 1 tsunamis. These happen every few decades, maybe once every 150 years, 7 to 10 meters high. The new walls are designed to completely stop these. Full protection. Not a drop gets through. Level 2 tsunamis. The nightmare scenario. Once every 1,000 years, 40, 50 feet high. The walls cannot stop these. But, and this is crucial, they're designed to survive them, to not collapse, to slow the water down and buy people time to evacuate. It's brilliant, really. It's the engineering equivalent of saying, we can't win every fight, but we absolutely will not get knocked out. The numbers that break your brain. Right, let's talk about what they actually built, because the scale is genuinely insane. 400 to 432 kilometers of coastal defenses. That's not a wall, that's a fortified border. For comparison, the Berlin Wall was 155 kilometers. This is 3 times longer. Total cost. The initial estimate was $6.8 billion just for the seawalls. But when you factor in port reconstruction, land elevation, the emergency road systems, the total reconstruction budget hit $255 billion. That's 31.5 trillion yen. That's more than New Zealand's entire GDP. Height? Anywhere from 7.2 meters to 15.5 meters. The tallest sections, in places like Taro and Rikuzentakata, are 50 feet high. Stand next to one of these and you feel like an ant looking at a skyscraper. You cannot see the ocean. You cannot hear the ocean. The ocean, for all practical purposes, has been deleted from your life. 30,000 workers, engineers, crane operators, concrete specialists, geotechnical surveyors, all working simultaneously across hundreds of construction sites for 5 to 7 years straight. And the kicker, they're still not done. The Fukushima Daiichi nuclear power plant just finished its own dedicated 1-kilometer seawall in March 2024, because apparently one nuclear meltdown per tsunami is quite enough. Thank you very much. How do you even build this? The construction madness. So, how do you build a 50-foot concrete wall along 400 kilometers of active coastline, where waves are constantly smashing into you, where the ground is sandy mush, and where every section requires custom engineering? Let me walk you through it, and trust me, this is where it gets properly mental. Phase 1. The lab work. Before they poured a single cubic meter of concrete, Japanese engineers recreated the 2011 tsunami in massive wave tanks. They built scale models of walls and smashed artificial waves into them over and over and over, adjusting the height, the thickness, the slope angle, the foundation depth, until they found a design that wouldn't topple. The result? A gravity seawall with a base width that's 50 to 100% of its height. So a 14-meter wall has a foundation extending 15 to 20 meters inland. It's shaped like a massive trapezoid, narrow at the top, absurdly thick at the bottom. Pure, immovable mass. Phase 2. The foundation. Nightmare. Now, here's a problem. Much of the Tohoku coastline sits on sand. Wet, unstable. Seaside sand. You cannot just plop a 50-foot concrete wall on that. It'll sink, or slide, or crack in half the moment a big wave hits. So what did they do? They drilled steel pipe piles, sometimes 20 to 25 meters deep, straight down through the sand and into solid bedrock. Then they added layers of crushed stone, compacted sand, and massive concrete foundation blocks to create a base so heavy, so wide, that the wall physically cannot move. In some sections near the shoreline, they had to build temporary cofferdams just to keep seawater out, while they dug foundation pits below sea level. Imagine trying to dig a hole at the beach while the ocean is actively trying to refill it. Now do that for 400 kilometers. Phase 3. The caisson drop. For offshore breakwaters, the walls that sit out in the harbour to protect ports, they use something called the pneumatic caisson method. And this is proper sci-fi stuff. They built enormous reinforced concrete boxes, some the size of apartment buildings, weighing thousands of tons, in dry docks on land. Then they floated these giants out to sea, using specialized floating cranes with 300-ton lifting capacities. Once positioned, they sank the caisson by flooding it with water or concrete ballast. But here's the mad part. The bottom of the caisson is a pressurized air chamber. Workers, or robots, go inside this chamber while it's underwater and excavate the seabed from below, allowing the caisson to sink deeper until it hits solid bearing strata. They did this at depths of up to 22.5 meters, in tidal currents moving at 2.15 meters per second. It's construction, underwater, while the tide is trying to sweep you away. The towns that moved uphill. But wait, there's more, because the seawalls were just part of the defense strategy. Japan also decided to raise entire towns. I'm not exaggerating. In places like Rikuzentakata and Minami Sanriku, they looked at the downtown areas, completely flattened by the tsunami, and said, right, we're moving this 10 meters higher. They excavated nearby mountains, millions of cubic meters of rock and soil. They built conveyor belts, nicknamed the Hope Belt, stretching kilometers from the mountains to the coast, running 24/7, dumping fill material to literally elevate the ground level of the town. The logic was simple. Even if the seawall fails, even if a level 2 tsunami crashes through, the buildings will be sitting on high ground above the flood zone. It's defense in depth, multiple layers, redundancy, and then they planted forest, not the shallow-rooted pine trees that got uprooted in 2011 and became battering rams. No, they used the Miyawaki method to plant dense groves of deep-rooted native broadleaf trees, species like oak, chinkopin, and tabanaki, trees that anchor into the soil. The idea? The concrete wall stops level 1 tsunamis. The forest behind it slows down level 2 tsunamis, catching debris, increasing hydraulic resistance, buying precious seconds for people to run uphill. Grey infrastructure and green infrastructure working together. It's almost poetic. The environmental massacre. Now, here's where the story gets uncomfortable. Because while Japan was busy building this fortress, they were also destroying something irreplaceable: the intertidal ecosystem. The construction of these walls physically buried the sandy flats and muddy zones where the ocean meets the land. The base of the walls, remember, up to 20 meters wide, just paved over critical habitat for crabs, sea cucumbers, starfish, polychaete worms, bivalves, all the benthic organisms that form the foundation of the coastal food chain. And it gets worse. Vertical concrete walls reflect wave energy back into the ocean instead of letting it dissipate gradually over a sloping beach. This creates turbulence directly in front of the wall, scouring away the remaining sand and sediment. It's called passive erosion. The wall doesn't just block the water, it actively removes the beach. Research from Tohoku University found that the 2011 tsunami itself wiped out 30 to 80% of indigenous species in the intertidal flats. But instead of allowing natural recovery, the new walls prevent these ecosystems from regenerating. The beach, quite literally, no longer exists. It's just deep water and concrete. The sociology of a concrete prison. But the environmental damage? That's not even the most controversial part. The real fight is about what it's like to live behind these walls. Imagine waking up every morning in a fishing town. Your family has lived here for generations. Your father was a fisherman. His father was a fisherman. The ocean isn't just your job. It's your identity. It's your culture. And now you wake up and stare at a 15-meter concrete slab. You cannot see the ocean. You cannot hear the waves. You cannot judge the weather or the sea state. Fishermen in Akahama, people whose survival depends on reading the ocean, are now blind to it. Residents describe it as living in a prison, a concrete box. The Japanese government essentially said, "We will save your lives by destroying everything that makes those lives worth living." And the resistance was fierce. In Akahama, fishermen vehemently opposed the 14.5-meter wall. They argued it would kill tourism, ruin their way of life, and create a false sense of security. They proposed a lower wall combined with better evacuation routes. The government built the 14.5-meter wall anyway. Here's the cruel irony. These walls are designed to protect towns, but the towns are dying. Tohoku's population is collapsing. Young people are leaving. The towns protected by these billion-dollar walls are becoming ghost towns. By 2050, many of these municipalities may be empty. Who's going to maintain 400 kilometers of aging concrete when the tax base has evaporated? It's the reconstruction paradox. The infrastructure built to save the region may have destroyed its future. The false security debate. And then there's the most dangerous question of all. Do these walls make people complacent? Critics call it the safe island myth. The idea that visible massive walls encourage people to stay in danger zones instead of evacuating. That residents will hear a tsunami warning and think, the wall will protect us. This isn't theoretical. In 2011, Taro had its Great Wall, and people trusted it. Some didn't evacuate. They died. But, research from Purdue University analyzed data from the 1896, 1933, and 1960 tsunamis and found that seawalls did not statistically reduce evacuation rates. In fact, walls taller than 5 meters were correlated with lower death rates and reduced building damage. So the walls work if people still evacuate. The danger isn't the wall itself. It's overconfidence. It's forgetting that level 2 tsunamis don't care about your concrete. The real world test. So, does it actually work? On March 16th, 2022, Japan got its answer. A 7.4 magnitude earthquake struck off the coast of Fukushima. Tsunami warning. Waves generated. The new seawalls held. The waves in Ishinomaki port in Miyagi Prefecture, only 20 to 30 centimeters this time, washed harmlessly against the foundations. At the Fukushima nuclear plant, the water flowed around the base without causing structural damage. The scour protection systems worked exactly as designed. It wasn't a level 2 event, not even close, but it was proof of concept. The walls can do what they were built to do. The verdict, fortress or folly. So here we are. 400 kilometers of concrete, $255 billion, 30,000 workers, 5 to 7 years of construction. The longest continuous coastal defense system ever built. It can stop level 1 tsunamis completely. It will survive level 2 tsunamis, probably. It has destroyed ecosystems, definitely. It has severed communities from the sea, undeniably. It may create false confidence, possibly. Is it a triumph of human engineering, or a monument to hubris? Is it the wall that will save Japan, or the concrete coffin of coastal culture? Honestly, it's both. Because Japan looked at the ocean, the thing that has shaped their entire civilization, and said, not this time we fight back. And whether that's inspiring or tragic depends entirely on where you're standing. The waiting game. The Great Wall of Tohoku is complete. The concrete has cured, the gates are operational, and now we wait. Because the next big tsunami isn't a question of if, it's a question of when. And when it comes, the world will be watching to see if Japan's $255 billion gamble pays off. If you want to see more mega projects that push engineering to the absolute limit, hit that subscribe button and drop a comment. Do you think Japan made the right call? Would you want to live behind one of these walls?